Hello, in this video we're going to introduce unit vectors and unit vector notation. A unit vector is a vector with length 1. One without any units, just one. And the purpose of a unit vector is to represent direction. So if we drew our coordinate system over here with x-axis, y-axis, and z-axis, we can draw a unit vector to go along with each axis. Generally speaking, unit vectors match up with an axis. So we have one in the x direction, we have another unit vector in the y direction, and a unit vector in the z direction. And to distinguish these from other vectors, instead of putting the normal arrow vector sign, we instead use a hat or a caret. We're going to call the unit vector that goes in the x direction I hat. For the y direction, we'll call it j hat, and for the z direction, we'll call it k hat. You may find other sources that call these unit vectors x hat, y hat, and z hat, but our textbook uses I, j, and k, so that's what I'll use here. So those are our unit vectors. And their biggest use at this point is a different way of representing vectors. Instead of as a magnitude and a direction, so say we have vector v here, we could describe its length and which direction it's pointing, or we could write it using unit vectors and its components. And the trick here is that if we think about v, it could be the same, we could get to the same place if we went just in the x direction and then turned and went just in the y direction. And we added these two vectors together, this first one and the second one, that would give us vector v. So we're representing it as an addition of two vectors that are lined up nicely. Well, this vector here has length vx, which is the x component, and it has direction equal to I hat. And the vector over here has length vy and direction equal to j hat. So remember, I hat and j hat are short, they just have length 1. But we can multiply 1 by the length of each side, and that's how we get this vx I hat and vy j hat. And we could say then that v is equal to vx I hat plus vy j hat. So we're using the two components here to represent vector v. Okay, so that's a two-dimensional example. Let's look at a more general three-dimensional case. So in 3 dimensions, our vector v would be represented as vx I hat plus vy j hat plus vz k hat. So another way of representing vectors, and the real power for this is it makes it very easy to add vectors, and it's another way that we'll see coming up later to multiply vectors. So different notation lets us think about things a little bit differently. All right, well, we'll see that in later videos. So until next time.